Welcome back to the today's class on advanced switchgear. Today we will be seeing about modifications of circuit breaker duty using shunt resistance. We are having two types of resistance. One is linear resistance damping and another one is non-linear resistance damping. So first we will be seeing about a linear resistance damping. Introducing a linear resistance across circuit breaker during interruption, restriking transients are damped. So we know that in resistance switching, we are using a linear resistance to damp the restriking voltage. Provisions has to be made for subsequent interruption of resistance circuit. So we need to make a provision to connect the resistance in a circuit breaker in between the contacts of the circuit breaker so that the restriking voltage amplitude and rate of restriking voltage can be damped easily. Two such circuits are shown in the figure. In this figure you can see a power system having an inductance L and a generator and two circuit breakers that is in the form of a gap. These two circuit breakers or these two gaps are connected in parallel with the series resistance across the gap 2. So in the second circuit you can see the two gaps, that is first gap and the second gaps, are connected in series, and the resistance, that is the resistance which is used to damp the voltage or oscillation, is connected across parallel across the first gap. Resistance are switched into circuit by breakdown of ionized exhaust that are blown from gap 1 and 2. So, while a arc is being interrupted, at once the ionized gases which are created will tends to decrease the capacity of the arc so that the resistance will be automatically added in the gap 1 and gap 2. So the arc current will flow through the resistance as well as through the ionized particles present in gap 1 and gap 2. Immediately after gap 1 has ceased to carry current, gap 2 is still fed by hot ionized air, which causes it to be broken down by restriking transient in preference to gap 1. So the gap 1 which is carrying current will first cut off the current through it, and then the gap 2 will cut off the arc. So at the present scenario, the gap 1 will first cut off the current, and the gap 2 will cut off the current. Here the current is represented as a arc. So in first point the gap 1 will extinguish the arc, and the second time the gap 2 will extinguish the arc. While extinguishing the arc, the current which is flowing in the arc will be passed through the resistor R, which is connected in series or parallel with the gap. At next current 0, gap 2 is fed with cold ionized air, and resistor current is in turn broken. So once the gap 1 is trying to cut off the arc in first current 0 position, whereas in gap 2 the gap 2 will try to cut off the arc in the second current 0 position. So by increasing the temperature which is created by the arc is to be decreased. So a fresh cold unionized air particles are blown into the gap 2 so that the medium gets deionized and the temperature in the gap 2 becomes reduced, so that the resistor current will broken as well as the arc current will also broken, so the arc get extinguished. In figure, the arc is shunted, gap 1 is extinguished first, and the resistor then shunts L and C. So on seeing this figure, you can see the gap 1 current, that is the arc current, which is extinguished first. So the current which is passing through the gap 2 is present, whereas the gap 1 has extinguished the arc. So this causes the inductance and capacitance to be shunted through the resistance R through this path until the arc carrying current until the arc carrying resistor current in gap 2 is extinguished. So this that is the above phenomena, that is the shunting of inductance and capacitance through the resistance across the gap 2 will occur until the gap 2 is ionized or the gap 2 is conducting the arc. So once the gap 2 tends to deionize and the arc is broken in gap 2, at once the resistance will be broken and the resistance current will also broken. By this time voltage transient decays down. So while the current is broken, the transient current and the transient voltage get decays. It will thus be noted that voltage transient encounter on finally clearing circuit is impressed on gap 1 and gap 2 in parallel in case of figure B. So in this figure you can see the total current which is flowing across gap 1 and gap 2 are the same. So the arc created will also be the same. So once at current 0 position, both the arc current and the arc will get decreased at the same time in gap 1 and as well as gap 2. So the arc current will tend to flow through the resistance R through this path. For capacitive current breakings and current chopping, gap 1 can be proportionated solely to clear rated breaking capacitance current. So while breaking a capacitance current, the gap 1 tends to play a vital role because this gap 1 is connected in parallel across the shunted resistance, which is a linear resistance. In practice, it is found that arrangement is mostly suitable for breakers of 33 kV and below. So we are using a linear resistance for arrangements in the figure shown above can be used only for breakers less than 33 kV and below. For this arrangement in figure is most suitable for breakers of 66 kV and above. So when linear resistance is used for breakers more than 66 kV, then this arrangement is used. This is because of voltage up to 33 kV, high restriking rates may be associated with the maximum fault MVA likely to be experienced. So the voltage rating, that is the high restriking rates voltage rating, can be associated with the maximum fault current MVA which is experienced by the breaker. This differs from conditions found on high voltage networks where couple times tends to reduce rate of rise of restriking voltage at a large fault MVA. So in low voltage breakers such as 33 kV breakers, the high voltage networks which are present has a very great difference. So the breaking capacity of the breaker is also get differ. In case of a 33 kV rated circuit breaker, the breaking capacity is less, whereas in a breaker of 66 kV, the breaking capacity of a large fault current in MVA is present. So circuit breakers having a very high large fault current and a very high rate of rise of restriking voltage are used. Figure shows diagrammatically linear resistance applied to an air blast circuit breakers. So in this figure you can see a circuit representation of an air blast circuit breaker where linear resistance is connected across the two contacts A and B, and the arc is formed at this point, whereas the air is blown to extinguish the arc. So these two contacts A and B are connected across a linear resistance R. And this is the another part of the circuit breaker where the complete power system is connected over here. Here the generator is shown and the generated magnitude is voltage G, and the circuit impedance which is present as an inductance is shown here, and similarly the breaks, that is the gaps present in the circuit breaker are shown as A, B and C, and the linear resistance which is connected across the path is shown in the above figure. Figure shows current voltage curves for inductive current interruptions. So in this figure you can see the current and voltage waveforms for inductive current interruption. So this is the arc voltage and this is the resistance which is inserted at this position when the current starts to go towards a negative position. After the final interruption of arc current by the help of resistance which is inserted, then the recovery voltage starts to establish at this position. For systems such as 132 kV bar 400 kV, use of shunt resistors in case of blast circuit breakers has very less important. So when the system voltage is more than 132 bar 400 kV, then shunt resistors must be employed in a blast circuit breakers, which is very less important in case of when a low voltage system is considered. Thus, such a use of resistance results reduced duty on main interrupters. So, the main use of adding a linear resistance across the contacts of the circuit breaker is that the duty of the interrupter, that is the duty of the main contact to interrupt the arc extinguishing property, get reduced. Additional apparatus required for interruption of resistor current tends to increase complication of complete force blast circuit breaker. So while using or while adding additional apparatus to interrupt or to extinguish the arc current with the help of a resistance, so while adding a resistance across the contacts of the circuit breaker, then additional complications are present in a force blast circuit breaker in all cases where shunting resistors are provided. So in all circuit breakers where a shunting resistor is provided, then there will be an additional apparatus or interrupter design where the resistor current needs to be more than the arc current. So extra cost and extra complication in circuits are present in air blast circuit breakers when employed with resistance braking. In case of current exceeds 200 amperes, auxiliary contacts themselves must have some form of arc extinguishing blast. So while the current rating exceeds above 200 amperes, then with the help of resistance damping, as well as we also need to provide auxiliary contacts with arc resisting properties, so that the auxiliary contacts themselves must have some form of arc extinguishing blast. So in blast circuit breakers, in auxiliary contacts also a stream of flow of blast air is provided, so that the arc is extinguished when the current exceeds about 200 amperes, as well as the resistance damping is also used in the circuit breakers. For self-blast oil circuit breakers, most onerous duty respect to rate of rise of restriking voltage and voltage peak tends to occur at a relatively low fault values of order 10% to 30% of braking capacities. So for self-blast oil circuit breakers, with respect to rate of rise of restriking voltage peak will occur at a very low fault currents, and these rate of rise of restriking voltage peaks will have a braking capacities at a higher value at the order of 10% to 30% of the original braking capacity of the circuit breaker. Under this condition, presence of arc control device is low at time when high system rate of restriking voltage is associated with 100% recovery voltage peak. So in an arc control device with a low rate of rise of restriking voltage and a high system recovery voltage need to be associated to get a 100% recovery from the arc voltage. This overcome by connecting linear resistance in parallel will pass sufficient current to limit the rate of rise of restriking voltage. So this phenomena we have studied already in the resistance switching, so that when R current is flowing across the two ends of the circuit breaker at once, the R current should be passed across the linear resistance which is connected in parallel across the circuit breaker contacts, so that the R gets stabilized and the rate of rise of restriking voltage get reduced to a lower value. If sensitive of design is attributable more to restriking voltage peak than to a rate of rise of restriking voltage, account must be taken to that value of system constants when transmission lines of large capacitance are coupled. So when a large capacitive lines are achieved, then the restriking voltage peak may increase to a very higher level. So the design insensitivity of restriking voltage and the rate of rise of restriking amplitude depends on the value of resistance which is inserted across the circuit contacts. With such designs, when capacitance is large, much larger shunt currents are required to ensure your critical damping. So, on using a design for interrupting a large capacitor currents, a larger shunt currents, which requires to ensure a critical damping level. Figure shows two brake circuit breakers shunted by linear resistance interrupting fault current which occurs during initial part of contact travel. So this is a oil circuit breaker. You can see we are having two brake oil circuit breaker, and at the end of here you can see the linear resistance which is connected across the fixed and the moving contacts. So this is the one resistance used for one brake, and this is the another resistance which is used for the second brake. You can see this oil circuit breaker is employed with the additional device which is seen earlier, which is the expansion pot. So this expansion pot will also help to interrupt the arc, and in the same time the resistance which is connected acts as a resistance damping. In a oil circuit breaker, shunt resistors absorbs electrical energy and converts into heat energy during small inductive current interruption when over voltage oscillations are produced by current chopping. So these shunt resistors will absorb the electrical energy present in the arc and converts the arc energy into heat, so that the small inductive currents can be interrupted when over voltage oscillations are produced due to current chopping effect. Since this complete setup is immersed in oil, the resistance which is heated and the heat will be dissipated in the oil. Nonlinear resistance damping. Shunt nonlinear resistors are especially suitable both from space and reliability consideration for small shunt currents. So, where nonlinear resistance are used, the circuit breaker space gets decreased and the reliability consideration of the circuit breaker gets increased. Where wire wound resistors tends to be less satisfactory on mechanical grounds. So in olden days we will be using a wire wound resistors which is very bulky, and the size of the wire wound resistor is also large. So on installing such type of wire wound resistors increases the weight as well as the size of the circuit breaker. So it performs very less satisfactory on mechanical grounds. Very high, very heavy currents are involved. There may be difficulty in accommodating the relatively large volumes of resistor materials that is required. So when a very heavy current is associated with the arc, then it is very difficult to accommodate a very large high volume of resistor material because a wire wound resistor has a very less resistance when compared to other porcelain or carbon resistance. So when a wire wound resistance are used, then when a heavy current is involved, a large amount of wires of higher grading resistance is needed. So this is very difficult to achieve such a very high resistance using a wire wound resistors. Non-linear resistors are practically suited to voltage divisions and over voltage suppression applications. So the nonlinear resistance, which are practically suited to voltage divisions and voltage over voltage suppression applications, can be used for nonlinear resistors types. So while using in practical application, nonlinear resistance are suited for voltage divisions and over voltage suppression applications. Literally, small current of the order of 1 ampere to 10 ampere at a normal crest voltage are adequate. They are not suitable for modifications of rate of rise of restriking voltage and voltage peaks. So nonlinear resistance damping is not suitable to modify the rate of restriking voltage and also the restriking voltage peaks. It is only useful to divide the voltage division and also to suppress the over voltage which is present due to harmonics as well as the current interruption process. Linearly, small currents of the order of 1 ampere to 10 amperes is adequate as a crest voltage. So, nonlinear resistance can be used to interrupt only a very small current of the order of 1 to 10 amperes. Figure shows a schematic arrangement for voltage grading with the help of nonlinear resistors in oil circuit breakers and air blast circuit breaker. So this is the oil circuit breaker figure and this one is the air blast circuit breaker figure. So nonlinear resistance can be used only in blast type of circuit breakers, whereas it cannot be used in other similar circuit breakers which are not employing blast circuitry. Nonlinear circuit breakers ensures accurate voltage division across breaks and because of rapid increase in shunt current with the rise in voltage. So the main advantage of using nonlinear resistance is it is used to accurate voltage distribution across the breaks. If there are 2 breaks or 3 breaks across a pole, then the distribution of voltage across each pole should be similar and should be equal. So to ensure this process, the nonlinear resistance can be used to ensure the accurate voltage distribution across the breaks. It also suppresses over voltage when switching small inductive currents. When a small inductive currents are used and suppression of such small inductive currents can be made using the nonlinear resistance damping. The current is interrupted without difficulty by sequence isolator in oil in case of oil circuit breaker. So the small inductive currents can be easily interrupted in oil circuit breakers with the help of nonlinear resistance damping. Capacitance can also grade voltage distribution across multi-breaks. It cannot damp voltage. So when nonlinear resistance damping is used, the grade voltage distribution across the multi-breaks, it cannot damp voltage when capacitance are used. So it is a disadvantage of nonlinear resistance damping when used across a capacitance damping. To equalize voltage distribution across 2 or more breaks, high values of 10,000 ohm to 1 lakh ohms are required to suppress over voltage due to current chopping in air blast circuit breaker. So the nonlinear resistance damping, the resistance value which will be equal to in the order of 10,000 ohms to 1 lakh ohms, and this higher ampere rate, this higher ohm rating is used to suppress the overvoltage due to current chopping in air blast circuit breakers. To avoid damage when switching capacitive current, 2000 ohm to 5000 ohms of nonlinear resistance is required. To control rate of rise of restriking voltage values of 1000 ohms to 2000 ohms required for oil circuit breakers. So to control a rate of restriking voltage using a nonlinear resistance damping, then the value of resistance required for a oil circuit breaker is 1000 ohms to 2000 ohms. So this figure shows the ampere rating and the ohms required to interrupt arc current with the help of nonlinear resistance damping. You can see the arc voltage and the chopped voltage and the high restriking peak current which is occurring during the resistance damping using a nonlinear resistance, and this is the resistance current which is interrupted using nonlinear resistance, and this is the time period where the resistance will be loaded for a short duration of time with a high current in amperes. So this is the power system diagram where a nonlinear resistance is used. Thank you.